Hi, let me introduce Professor Alex Anas from the State University of New York at Buffalo. Professor Anas works in the area of urban economics, and his specialty is the computable models of city economy, including interaction between sectors inside the city, different sectors of the economy and transportation sector. So Professor Anas is author of 3 books and 80 or more than 80 scholarly articles and book chapters, and he's a recipient of numerous awards. He worked with this project on constructing computable models of urban economy for Chicago, for LA, for Paris, and probably some of cities I don't even know about. So please welcome Professor Alex Anas.
Thank you. So I'm very pleased to be here and to talk to you. Let me just lay out the format of the talk. I'm just going to go through a PowerPoint presentation. I will make comments about what I learned when I studied these 3 places, Chicago, Paris, and Los Angeles. And the Chicago and Paris were studied in pretty great detail, so the studies on those are complete. But Los Angeles is not yet complete, so I'm just going to make some comments about what I anticipate to learn in Los Angeles, and I will have results within a year from now, I think. So as I talk, you can stop me anytime you feel like asking a question. Just let me see that you want to ask a question, and I can answer your question. At the end, there will be plenty of time for discussion if you want to wait until the end to make comments or ask me additional questions. Okay, so as was mentioned, I'm an urban economist, so I study cities, and these are 3 very different cities. They have important differences in their structure and the way they are organized, which should become clear as I make the presentation. They have very different histories. For example, Los Angeles is the newest of the cities, and it really started existing as we know it today only about 150 years ago. Before that, it was really not really a city, actually. But even though they are so different, what's interesting, if you're an urban economist, is that the processes that shape these cities are the same processes. The markets work more or less the same way. There are important differences, of course, in government policy and so on that also affect things. So if you understand how the process works, you can model any city pretty much using the same tools and the same types of mathematical concepts and economic concepts. I do computable general equilibrium models, and in very simple words, what's a computable general equilibrium model is that you try to model all the markets that are relevant to how a city works. For example, transportation, labor market, housing market, government decisions, and so on, in a way that takes into account how they interconnect with each other. So if something happens primarily in one market, it will have effects in the other markets, and these effects eventually feed into each other. So you have to solve the whole system together. Okay, that's basically a very non-technical way of explaining what's a computable general equilibrium model. It's based mostly on microeconomic theory, not macroeconomic theory at the city level. Urban economics is largely a microeconomic discipline, and we use econometrics to estimate the equations of these models and to make them work in a scientifically valid way by fitting them to data. Okay, so let me talk about the model I've developed, which is called RELUTRAN, which means Regional Economy, Land Use, and Transportation Model. This is the same model that was applied to all 3 areas. So Chicago and Paris has been studied, as I mentioned, and we're now trying to complete the study of Los Angeles with the same model. I will sort of give a very rough way of the way the model works, and I'm not going to go through all the details you see here. So basically there is a land use and regional economy model, which is this one here. And then there is a transportation model. And these are linked with each other. So imagine how transportation economists study a city. They take the land use as given, That's very important because it tells them how trips will be generated and how many people who live in a certain area will travel to another area either for work or for some other reason. Then they know a great deal about the transportation network, both public transit and highways, and they will load these trips onto the network. So they study how people choose how to go from A to B, from point A to point B within a city. That's the kind of thing that we model in this part of the general equilibrium model. But we don't take the land use as given. So we know that as people make travel decisions, eventually the process will feed back and the land use will change. So suppose that a lot of people go from point A to point B, there may be a lot of congestion that occurs on the roads connecting A and B, especially, let's say, if there is no way to go from A to B using public transportation, and the easiest way to go is by driving, then there will be a lot of congestion. So it's going to be very inconvenient to be located at point A and to be going to point B. So what will happen over time is that people who are located at point B are going to move closer to point B. At point A, closer to point B, or some of the opportunities that they visit at point B may move closer to them. So this is just a very simple example to show that the land use, the way activity is organized within the city, where the jobs are, where the housing is, where the shopping is, where the government offices are, and so on, are going to adjust over time to the congestion that happens on the traffic network and to the public transportation network, accessibility, and all those types of things. So the land use is not independent. So transportation modelers all over the world typically study this process very well, in a great detail, but they keep the land use fixed. What I do and what some other people do in this field is to try to model how changes in transportation will affect the land use, and then how the land use will affect transportation. So that's one of the features of the model that's important in understanding some of the results that I will talk about in a minute. And what you see here is just a more detailed breakup of what's going on inside this box. So inside this box we have all the markets that are important in the urban area. For example, this is the prices of goods, how the prices of goods are determined. So how much you pay for a cup of coffee would be an example of that, although the model is not detailed enough to tell you about the price of coffee in particular. And so firms make decisions of where to locate, and based on the cost of locating in a particular place, that has an impact on what kind of prices they would charge their customers. So that kind of thing happens in this box up here. Then this box tell me how much will be produced of the different goods in different locations. And also because firms are making these decisions where to locate, what price to charge and how much to produce, wages are going to be determined that way, because that's going to imply certain demand for labor as they make their decisions of how to produce and so on. So wages will be determined in the labor market, and rents will be determined in the market for floor space that the firms have to use. And then from there we go to values. So what happens is that if you're a land developer, you create buildings for businesses to use and for people to use. What you're going to do is you're going to look at the value of the floor space you create, how much it costs to create it, how much the land costs, and that's going to lead to a decision of how much you want to build, how much new floor space to create. So floor space will occur or will grow by construction in those places where firms are profitable. And this holds not just for firms, but also for consumers. So consumers will locate in places that they find is more convenient to them, except they will consume residential floor space, not commercial floor space, but then the process will be very similar. So I'm not going through this in great detail, and you can read some of my papers if you're mathematically inclined. There's a lot of technical things here. If you're not, you can just forget about it. It's not important to go into this detail for this presentation. Now I'm talking about this box here, the second box, which is the transportation part of the model. So typically what happens here, we take trips from the first part of the model. How many people go from A to B using all the A's and all the B's that are available. and then we load those to the network, and we get how many people want to drive, how many people want to take public transit. If people want to drive, they have to decide which route to take to go there, just like the cab driver that brought me here. He had this very interesting and sophisticated looking GPS. I was constantly checking to see how to come here. I think he was choosing routes. I'm not exactly sure exactly what he was doing, because I haven't seen this kind of GPS in the United States. It seemed very advanced to me. But he was definitely concerned about how to get here, because he had a time constraint. So that's exactly what he was doing. He was making a route choice. And when people choose the same route, then congestion happens, so it becomes harder to travel on that route. The travel time goes up. That means there's an equilibrium process where if many people want to go from A to B using a particular road or a particular sequence of roads, then those roads will become very congested. So they will try to go another way, and the other roads will become very congested, and then the congestion will spread throughout the system. Right? Okay, and so this process creates travel times, and using these travel times, we can go back and see how the travel times feed back into ReLU, and go through this process, and then go to the next process, and so on. And finally, in this way, we solve the model. Now I want to give you a more sort of behavioral picture of how the model treats the behavior of the consumers. Okay, so we have consumers in the model, and they make different decisions. And we try to model this using microeconomics. So they choose between things like where to work and where to have their house, or whether they want to be out of the labor market. Some people may decide, I already have enough money, I don't want to work, because the roads are very congested. Very few people are going to do that, because whether you want to work or not is determined by other things. But there's going to be some people who might do that, so at the margin you may have even that kind of response available. And then once they make these decisions, where to work, where to reside, they also decide how many hours to go to work. There may be some flexibility on that. And whether to go by car or by public transportation, what kind of housing to have, how much housing to have, whether it's going to be a big house or a small house. So typically, if you want to be very near a highly congested area, rents are going to be high. So you will save travel time by locating there, but you have to pay a lot of rent per square foot or per square meter, so you're going to buy less housing. You may live in a small apartment, but have a very convenient commute to work. That's the kind of trade-off I'm referring to here. You may also decide what kind of car to have, because if you have a car that consumes a lot of gasoline and you have a very long commute, that's going to be expensive. So you may switch to a small car that's less comfortable, that is going to be cheaper. In the US, this is a very important trade-off, because most of us drive very big cars, and so switching to a small car for some people becomes very important in order to save money. Okay, and then you have to decide, if I locate in this particular place, well, I can choose my housing, I can choose how many hours to work, I can choose what kind of car I want to own, but now I have to decide, am I close enough to shopping opportunities? Right? How many times am I going to go shopping from here? How far am I going to go? How many trips per period I'm going to make? All those decisions are important, so they are in your model. They're in the model that I have. So that gives you some idea how the model is built without going into any mathematical details and so on. If there are any questions now, I can answer about these kinds of things that I just talked about. Okay, so let me continue then. And this is, I'm just going to skip this because this is basically the same thing presented in a different way. And now the model has different firms in it. They are producing something. The firms are producing something, and so there's a production function, and they decide what kind of labor to employ, skilled or unskilled and so on, what kind of buildings to be located in, and what they need to buy from the other firms. And then they produce an output. So you can imagine that all the firms are trying to do this, and there is something that connects the firms with each other, which is what they buy and sell to each other. So if I want to produce a particular good, a retail good, for example, that I sell directly to consumers, I have to be near consumers. That's important for me, because I want to make it easier for consumers to come to my store, which means the demand for my good will be higher. And that means maybe I can charge a higher price for my good. But it also means that I need to be close to warehouses and the other firms which supply me the goods that I sell. So I want to locate as a firm in such a way that I'm close to where I get my materials and my goods and close to my customers at the same time. So in the Chicago version of the model, we had these industries: agriculture, manufacturing, business services, retail trade. And we assume that the consumers buy directly from retail trade, but these industries are linked to each other. So there was a famous Russian economist, Vasily Leontief, who got the Nobel Prize, and he studied in his career how different industries interact with each other. This part of the model basically follows that kind of logic, looking at the way the industries interact with each other. And that depends on how much they need each other to produce. So if I have an industry that needs a lot of business services, it wants to locate in a place where there is a lot of business services available. And if I have an industry like retail that sells directly to consumers, it wants to locate in a place where it's accessible to consumers and so on. Okay. So now, using this kind of model, one of the things that I'm studying in all the three cities, namely Chicago, Paris, and Los Angeles, is the connection between congestion, traffic congestion, and urban development. There are many other issues I could study, and some of them come up indirectly, because I'm modeling all the markets, as I said before. But the particular interest is to look at the relationship between congestion and urban development. So I want to look at this question: how does urban development respond to increases in traffic congestion in these three places that I mentioned? The same processes are at work. What do I mean by that? The decisions of the consumer that I talked about are the same. So economists believe people are the same everywhere in the world. They just face different circumstances. So if I take any one of you, or go to Africa, any African country, take any person there or anywhere in the world, I find they're all trying to do the same thing. They're trying to maximize their well-being using a budget constraint, an income constraint, and so on. But they face different circumstances, so the choices they make are different, but the process by which they make those choices is the same. So the same principle applies here as well. That means the people in Paris, Chicago, Los Angeles are all acting the same. They're all trying to solve the same problems, but they face different prices. They face different, some cultural things, maybe different as well. But they're all basically trying to solve the same problem. So we can use the same theory, the same microeconomic model to study all the three cities and other cities as well. So the main ideas that I can express, having done these studies, is that the way congestion affects urban development depends on several things. One of them is how much public transit is available. If there is very little public transit available, then a very high level of traffic congestion is going to be dealt with in a different way than if there is a lot of public transit available. Because if there is a lot of public transit available, people will try to avoid the congestion by switching to public transit. Not everyone will do that, because cars are normal goods, and we know in all the countries that grow, people want to have a bigger car, more cars, drive more, and so on. That is a constant relationship all over the world. And so people with high incomes, for example, are going to be more attached to their cars. They may be less willing to switch to public transit, but there is variation even within people of any income, so some people will want to switch to public transit. And so you're going to get that if there is no public transit, nobody's going to be able to switch to public transit. And then what you're going to get is that people have to adjust in some other way. But if there is public transit, a lot of the adjustment to congestion will happen by people switching to public transit. A second type of adjustment is how the jobs are distributed within a city. So looking at American cities, for example, if I look at New York, in New York, a very large percentage of the jobs are in Manhattan. I think it's about 30 to 40%. But this is very, very high for an American urban area. It's much lower in other places. So in Chicago, it's only about 14%, which is the third largest metropolitan area. And in Los Angeles, which is the second, it's only about 4% of the jobs downtown. Whereas in Moscow here, my understanding is, I don't know enough about Moscow, but it's also a very high percentage downtown, or near the center. By downtown, I mean the area near the center of the city. So that's going to have a big effect on how the city will respond, because if those jobs are all near the center and the city is very big, you're going to have a lot of people away from where most of the jobs are, and a lot of those people are going to be working near the center, so they have to get to the center. And let's say that you don't have public transportation. It's going to be very hard to get near the center. You're going to have to endure a lot of congestion. And so how will the city respond to that situation? Well, an obvious answer is that the jobs are going to move out closer to people. And you might find that response. We'll see later that in Los Angeles, that's what we have for a number of reasons. The jobs are extremely dispersed in Los Angeles compared to Chicago and Paris. Paris is another example of a city where a very large percentage of the jobs, close to 50%, are located either in Paris itself or in 10 suburban growth poles, which are around Paris, that the French call pôles de croissance, growth poles, which are located around Paris. Okay. And we're going to see that that's shaped to a large degree by the availability of public transportation. Okay, so those are going to be important types of responses. We find that how much public transit is available is a big safety valve in dealing with congestion. If more is available, congestion will be kept under check because people will be able to switch to public transit when congestion goes up. That in turn will keep congestion lower than it would be otherwise. And if public transit is not available, then job distribution is going to be an important way in which the system deals with congestion. Okay, let's look at some numbers. So let's look at what percent of the trips are done with public transit. You'll find some of these surprising. So in Greater Paris, it's 50%. I think this is not too surprising. Most people would maybe guess that, I hope. In Chicago, it's only 13%. And in USA as a whole, all the urban areas in the United States, some 300 some urban areas, only 4.9% of the trips are by rapid transit, which is extremely low compared to Europe and some big Asian cities. And in Los Angeles, it's less than half of the national average, so it's 2%. Okay. So these are very different numbers. And so if I want to talk about what happens when public transit is extremely available, or available to a high degree, I should look at Paris, not at Chicago or Los Angeles. If I want to see what happens when public transit is not available, then I may want to look at Los Angeles because there's so little public transit in Los Angeles. And how about job concentration? So in Greater Paris, 50% are concentrated either in the city of Paris or in these growth poles. In Chicago, 30% of the jobs are in 4 job centers. One of them is in downtown, another one is the O'Hare Airport, the third one is the Schaumburg Suburban Business District. And in Los Angeles, 30% of the jobs are in 30 different job centers. So the jobs are very dispersed in Los Angeles. Now you may already be making a connection here that jobs are very dispersed in Los Angeles. At the same time, we said Los Angeles has very little transit. Maybe these things are related to each other. Maybe the lack of transit, which historically has been true in Los Angeles, is causing the jobs to disperse. Or maybe because the jobs are so dispersed for other reasons, it's very difficult to provide transit. Because if you look at the other cities, or any city in the world, there's very high public transportation. It's usually the public transportation feeding the center of the city, downtown. Most of the time it's radial lines which serves downtown because you need an economy of scale, a lot of people working and doing business or living in one small area, and providing public transportation for them becomes a lot more economical if that's the case. So if the downtown has a lot of activity, you're likely to find that people over time figure this out and they build transit systems to serve the downtown. Okay. Sometimes it develops the other way where you have foresightful planners, they build transit systems, and that causes the downtown to attract a lot of people. So there's simultaneity between these different processes. They are not independent from each other. Okay. Let's look at how decentralized trips are. So most travel in the United States occurs in the suburbs, not downtown oriented anymore. It used to be that way, but since World War II, things changed a lot, and a lot of the trips are suburb-to-suburb trips, which is something most people do not realize. So, and the effect is bigger when public transit is less available. Okay, so let's look at US versus Canada, considering all the metropolitan areas. So the people who live in the central city and work in the central city, people who live in the central city, work in the suburbs, and so on, all these are written down. And you can see that here, the very big percentage, or most of the trips, the majority or the big percentage in the United States is suburb to suburb. In Canada, it is central city to central city. But suburb to suburb is also very high. Canada has more transit than most American cities. And so that is possibly a consequence of transit availability. But it's not only that, there's also some other policies in Canada that cause this to happen. Okay, this is another thing I did. So if I take the 50 biggest metropolitan areas in the United States, so when we say metropolitan area, we mean the city and all its suburban area, all the functional units together that work as a single economy. And on the horizontal axis, I have a measure of how big the metropolitan area is. And this is measured as the total workers that are 16 years or older in the metropolitan area. So I'm using workers to measure the size of the area. I could also use population. I would get very similar results. But the reason I'm using workers is because every worker makes a trip. So that's a sort of more natural measure of size when I try to explain something about trips. And on the vertical axis I have commuting time. It's actually the log. I'm taking the logarithm of that and the logarithm of that. And I run a regression that explains commuting time of a person or a worker as a function of how many workers are in that metropolitan area. Right? So here, going from here to here, the metropolitan area is getting larger and larger in terms of workers and in terms of population too. And also, the average commuting time is getting larger and larger. The line I estimate slopes positively upward. Well, that says that as I increase the size, the average commuting time increases. And the question is, if I increase the size by 100%, so I take two metropolitan areas, one is twice as big as the other, by what percent will the average travel time increase? And so because this is log, that number is given by the slope of this line. So the slope of this line is an elasticity that tells me by what percentage the average commuting time will increase if the population or the number of workers increases by a certain percentage. Okay. And so when I show this to people, unless you're really good with logs, you cannot easily figure it out. Then people, or maybe I don't show this and I ask them to guess. Okay. So how would you guess? So suppose I take an American metropolitan area that has approximately 1 million workers. That would be, for example, Pittsburgh. And then I take another American metropolitan area that has approximately 2 million workers. That would be Houston. And I look at the average travel time in Pittsburgh and in Houston. I will find the average travel time in Houston, which is bigger, is going to be bigger than the average travel time in Pittsburgh. And going from Pittsburgh to Houston, I double the population of the city, measured as workers. How much, by what percent do you think the travel time will be higher in Houston? 10%. Okay, so you're very good with logs. Is that how you figured it out? That's perfect. That's what you want to do, right? You don't want to guess. Okay, but when I ask people to guess, they will give me a much higher percentage. Okay, because people have this perception that bigger cities are much more congested than smaller cities, which is true. They are more congested in the sense that there are more places where the traffic stops or slows down significantly. But here we're talking about total travel time, right? So something is going on, and the travel time is increasing only by 10% when I double the size of the city. This must be explained because there is some kind of process going on that is making it easier to adjust to congestion. That's the basic hypothesis that comes out of this. So if I look at specific points on that regression, I see, for example, Louisville has 500,000 workers. The average commute time, so commute means travel to work, when people go to work, one way, not coming back, just one way, is 22.7 minutes, and in Pittsburgh it's 25.5 minutes, so the increase is about 10%. Then if I double the population again, or the workers again, I add another 10% and so on, and in New York I have 34 minutes. So from the smallest city, or one of the smallest cities, to the biggest one, the increase is not huge. It's about 10% every time I double population. Or another way of looking at it is New York has 16 times more workers than Louisville, but only 50% higher commuting time.
Excuse me, this is a one-way or two-way?
One way. This is one way. You can multiply by 2 if you want to get an idea what's the total time you spend. Roughly by 2. It's usually the same amount of time to go back. Okay, so what's going on? And the explanation is that congestion builds up when you add more people, typically. In fact, the amount of road capacity per person goes down as we go to bigger cities. Bigger cities have more roads, but not proportional to people, so they get more congested for that reason, largely for that reason. Not only for that reason, but largely for that reason as well. And so something is going on to make this possible. Right? What's going on is that workers avoid congestion by switching to public mass transit. So sometimes it doesn't go up very much because good public transit is available. But of course, looking at my previous numbers, this is not a very good explanation for the US because only 4.9% people use public transit. So it's not going to make a huge difference, except maybe in some places like New York and some other places where a lot of people use public transit because it's available. But another thing that happens is that maybe people in jobs relocate closer to each other. So when congestion goes up, the way land use is distributed changes. And people in jobs end up locating closer to each other because they are responding to this congestion. This doesn't happen because one day they wake up and say, okay, we all have to relocate. No, it happens slowly over time. Every year a few people do it, and so over time it makes some difference. And then there's other responses we can think of. For example, carpooling would be a response where you say that, okay, I'm going to travel with another person. But this usually increases your travel time, so it's not a good response because you have to pick each other up in the same car, so it increases your travel time. So this is a good response to save money, because you can split the gasoline expense by carpooling. One day you use your car, the next day you use the other person's car, for example. But it's not going to save you time, it's actually going to increase time. So that's a response you would do if the money cost of transportation was very high. In the US, carpooling is extremely rare, and it's never became popular, so it's really not a significant response. So we can think about other responses, and I'd be glad to hear ideas for other responses, but these are the two main ones that I believe are occurring. Okay, but also firms are responding to congestion, right? So suppose you're a business and congestion goes up, that means your workers are going to have a harder time getting to work every day. It's more inconvenient for them. They have to get up more early or arrive later. They're not as happy. So how is that going to affect you? Would you care? And how would you respond to that? Maybe some workers don't want to work for you anymore. They want to work somewhere else, which is closer to their home, so they won't experience as much congestion. So how will that affect you vis-a-vis your workers? What will you end up doing? You may want to move closer to your workers, so that would be a response, right? Okay, I have the answers over there, so I shouldn't be asking this. So I'm using the so-called rhetorical style of lecturing, where I ask a question in order to dramatize the concept, and you can just read the answer I've written. That's okay. Okay, but I also have another answer, which is that you pay higher wages to attract workers. So I don't have to move. I can stay where I am and say, okay, I know you guys are having a hard time because you have to endure higher congestion and you want to work for other businesses, but I want to keep you because I'm happy with you. You're good workers, so I'm going to pay you higher wages. Okay. Both of those are...
Sorry, or you can
Yes.
wait just for some other workers who live closer to your firm to like sort of replace the current workers.
Yes, you can also do that, but maybe why weren't you doing that before, right? The reason you were not doing it before, because if that were true, earlier, before congestion increased, you could pay lower wages to those workers who are near you, instead of paying higher wages to workers who are farther away. Right? So this is what we call the sorting problem. You have a number of workers working for you, they live in different places, and somehow you've selected those workers to work for you. They've selected you because there's a good match in the type of work you require them to do and their skills. And you don't want to lose those workers. To some extent, you may end up doing that. So it may be an undesirable response to substitute workers who are closer to you, but they're not as desirable as the workers you currently have, because the workers you currently have don't want to commute to your location anymore because of the congestion. That's another response. But the two important ones that I want to focus on is you have to pay higher wages to attract them, or you move closer to them and then you don't have to pay higher wages. But moving is expensive, so in both cases you incur some kind of cost. So this is the kinds of adjustments that you might think would be dominant in the case of firms. And these combined effects now, firms are making adjustments, consumers are making adjustments, we discussed both of the adjustments. So if we combine the adjustments in the sense that both of them occur at the same time, then workers' response increases housing and job density in the centers of cities. Right? So suppose there is congestion, well, workers want to move closer to the firms. So to avoid congestion, I can reduce the distance I travel. If congestion is high for every mile of travel, I can reduce the effect of congestion on me if I can reduce the number of miles I have to travel. So that means I can move closer to where the firms are. The firms at the same time may want to pay me higher wages and so on. So what happens is that in cities where the firms cannot disperse and get closer to their workers, workers are going to move closer to the firms, and so many firms are in the downtown. For example, in Manhattan, this would be a very big effect, and workers would move closer to the downtown and rents would go up in the downtown because there's a limited amount of housing supply and demand will increase, so therefore housing will get more expensive. That's the kind of things that economists, urban economists have figured out both empirically and analytically that they do happen. Or, in some cases, firms' responses may spread them to outlying areas getting closer to their workers. Right? So that's also possible. That's maybe not likely to happen in Manhattan, or both processes could happen in the same place. Different businesses may be affected differently and so on. Okay, so we have found, just by reasoning the process, that households want to be near firms, firms want to be near households when congestion increases, and both of these processes go together at the same time. The net effect is very difficult to figure out. I cannot just tell you what will happen in a particular city. Even though I understand the process, I do not know what the net effect is, because the net effect depends on how strong each part of the process is. Right? That's why I need a model. The model helps me do that, because I can put numbers in it. I can estimate things econometrically and work out the equilibrium and find how the net effects are adding up with each other. Okay, there's something we're concerned about in the States called urban sprawl. Our areas are extremely spread out in terms of land. They're very big. The density of the cities are very low. And this, for some reasons, this is what you should expect should happen in the United States, because incomes have been pretty high over the decades. So when income is high, people want bigger houses. When each person wants a bigger house, then the urban area becomes more spread out and the density becomes lower. Also because there is not a lot of public transit. If there was more public transit, people would have to be close to public transit to use it. Public transit would serve the downtown, as we discussed before, and so that would keep the city from spreading out. In Manhattan, we see that that's sort of happening there. But in other areas, we see that the cities are very spread out and the densities are not very high. And that's because cars are normal goods, housing is a normal good, and so on. So US urban areas have adjusted to congestion by spreading out and jobs moving out to the suburbs. They were much more concentrated at the end of World War II in the centers. Now they're much more spread out. How much urban sprawl happened? So there's a study that shows that between 72 and 1996, the urbanized land has increased at the rate of 2.5% per year, but population only increased by about 1% per year. So that means land area, which is developed, not agricultural or empty, is increasing 2.5 times faster than population in city. And I can give an example from the area in which I live, which is the Buffalo Niagara Falls metropolitan area. So this is an area that has not grown since World War II. The population has been stable pretty much. You can see here that there was an increase and decrease, so pretty much stable since 1950, 50 years time span. But the land area has grown this way. So if you look at this axis, it's measuring the urbanized area. So I think it's grown about 4 times. Now think about how this would affect the city. The population didn't grow, but the land area grew. Right? How is it possible? So people call me up in Buffalo and ask me about this all the time. When they find out I'm an urban economist, it has happened maybe 4 times in the last 20 years since I moved there. Some journalist calls me and asks me, well, you know, why are people moving to the suburbs with all these empty houses in the center? This will cause houses in the center to remain empty, right? Because the number of people is the same, but they're moving out, so that means some houses that you see in the center are not really being used. In fact, that's what we have in Buffalo. It's what I like to call the donut-shaped city, where if you remove the houses that are not being used, you would get a donut. You know it's a donut, right? Okay, you may have 19 donuts in Russia, yes? Not yet? Okay, so Buffalo is an example of that. Right? Too much sprawl has happened, and all this land in the center of the city is underutilized. There's neighborhoods where 50 years ago there was a husband and a wife and 2 children. Now the children are gone to other cities because jobs are not growing in Buffalo, so they have to move to get a job. And maybe one of the husband or wife has died, and there's just one person living there. Or maybe both have died. Somebody inherited the house, but they keep it because they like to go back to Buffalo once in a while, or something like that. So it's this kind of thing very common in Buffalo. And the city has started a program where they try to buy these vacant houses to collect them together, so you get enough land together, then they can build something else there to revitalize the center. So that's an extreme example of how an urban area has affected sprawl. Now, some of you should ask me at this point, how much transit is there in Buffalo? Right? And the answer is it's not very high. It's about like national average or lower. We have a subway, which is just one line and goes not very far from the downtown, and it's the most heavily subsidized transit system in the United States. I think 80% of the cost is paid by the federal government, and only 20% from the users of the system. And so if there was more transit, maybe the sprawl would have been less, but in fact, there is not a lot of transit in Buffalo. So this also fits the transit part of the story a little bit. So this is a picture of how it grew. The yellow part is in 1950, and the red part is what was added since then. Okay. Let's look at Chicago. So how does congestion affect public transit, urban sprawl, and travel behavior in Chicago? And that's one question I've answered. Another question has to do with congestion pricing. But today I'm not talking about congestion pricing. So congestion pricing means that if there's a lot of congestion, you put a tax on driving. And you can do it in different ways, in a very accurate way or a very rough way. But no matter how you do it, the effect is more or less the same, which means people are going to stop driving as much, you will get less congestion. So they can do this by switching to transit. In a city where transit is very available, the tax doesn't have to be very high, because a moderate tax will cause enough people to switch. But if there is no transit available, they cannot switch. So you have to put a very high tax in order for them to do something else than drive. And then you may get jobs spreading out more. And this kind of thing was examined also using the ReloTran model, but I'm not going to talk about that today. I'm talking about the first question. So here's how the Chicago area was represented. We have the city of Chicago, which is that shaded area, and we have the suburbs, and we look at different geographic parts and group them together, so we have 5 areas or zones in the city and 9 in the suburbs and so on. And here's a more detailed level of Chicago, which we might do in the future, but we haven't yet modeled at that level. Okay, and this is the same thing as before, but bigger to show you the areas. And these are the places where cordons were put in, not in reality, but in the model. So the model is doing hypothetical tests. This was not done in reality. Okay, so if you put a cordon here, that means the trips that come in are paying a tax when they cross this line. And the way you pay it is electronically. It is recorded that you cross that line. You may pay later, or you may pay because there's a machine that photographs your license plate, and then you pay later. Or you can put the cordon here, or you can put it around the downtown. You can put the cordon in different places and tax people as they cross to reduce congestion. In London, they're doing that. In Stockholm, they're doing something similar to this. And this is, nobody has done this before, but I tried just to see what I can learn from it. So, people will try to avoid congestion in response to this pricing. So suppose my job is downtown, right? And I live out here, then if I don't change the location of my job, I pay a toll every time I go downtown. I may then switch to transit, but out here not much transit is available. And if I switch to transit, it will take even longer to go to work. So in order to switch to transit, I can move to the city, and I'll be closer to transit, then I can switch to transit. Or, if I'm living out here, I find a job near me and stop commuting downtown. That way I can avoid the toll. Both responses will reduce congestion. So if a lot of people do either one response or the other, congestion will go down. But as I said, there's a paper coming out in a new journal called Economics of Transportation that discusses cordon tolling in Chicago as a hypothetical policy. I'm not going to talk about that today, but I'm going to talk about something else we did. So what we did is we talked to the planners in Chicago, and they told us how much they expect the city to grow in the next 30 years. We just took their projections. So they expect population and employment to grow by about 24%, starting from the year 2000. So we actually did this in 2008, but we started from the year 2000. And went up to the year 2030 by growing population according to the planners' expectations. We asked them also, how much road capacity do you plan to add during this period? And they told us how much road capacity they're going to add. It was not very big. Okay. So obviously, if you don't add more roads and increase population, congestion should go up. Right? And then we want to see how the Chicago markets will respond to this. There's no congestion pricing. We're not pricing congestion. We're just increasing congestion by adding more people. And we want to see what will happen. How will the area change when this happens? And remember that regression line I showed earlier. So if I know, I expect that if I double the population of Chicago, I should get travel times to increase by 10%. So this may be a way to test that, because I'm now doing it with a model, right, which is going to increase the population of Chicago. It's not going to double it, it's going to increase it by 25%. Well, so I should expect the travel time to increase by about 1/4%. The elasticity is 1/10. Right? So that's the kind of thing I want to see, if that really is happening in the model that I've developed. Right? So as we add population, what happens? So one of the things that happens is the amount of empty land is shrinking, because the population has to go somewhere. They typically want to go where there is empty land and buy a big house. Okay, so that means the amount of land is going to shrink that is available. From agricultural, it will become more urban. And most of it is by building what we call single-family houses. Not apartment buildings, also apartment buildings. That's this line here. But not as many, because in the United States there's all kinds of regulations against high-density apartment buildings. And it's much easier to build single-family houses. And most of us like their own house. They don't like to live in an apartment building. We only live in an apartment building because we don't have enough money. We're very, very spoiled people. And so we like to have our big house, big car, and move out to the suburbs and so on. So that's what everybody's doing. So what's going to happen is that these things are going to increase and amount of land will decrease. The model generates this. So this is the output of the model. This is what the model is telling me is going to happen. And I could start comparing to see if this really happened. And I'm doing that a little bit because one of the things we find is that the planner's projections are not exactly accurate either. So I can rerun the model with the actual growth between, let's say, 2000 and 2010, and then keep updating to see what will happen. Okay, and here we see the aggregate VMT. What's VMT? VMT means vehicle miles traveled by car, because by vehicle referring to car, or maybe in some cases motorcycle and so on. So you have VMT increasing, aggregate VMT. Why? Because I'm adding more people. So of course I should expect VMT to increase. Maybe each person travel less, but since I'm adding more people, the total should go up. Right? But if I look at per capita VMT, it's decreasing. That means on average people travel less. As the number of people increases, road capacity is not increasing, so congestion is building up. If you add more people but keep the capacity the same, congestion should go up. Suppose everybody travel exactly the same way they traveled before. They don't change anything. They don't switch to transit. They don't change their job location. Firms don't move. You add more people. You don't increase capacity. Congestion has to go up. Okay? Then everybody's VMT, the per capita VMT should increase on average. But it's actually decreasing. Why is it decreasing? Well, the answer is in the clues I gave before. Something is happening. Jobs and residences are moving closer to each other. That's what's happening in the model. So if my model is accurate about the way behavior is modeled, because there's nothing in the model to force that result, it's the result of rational decisions and how the model is solved, then that must be an important effect. That's my conclusion. Now if I add capacity, so I said, well, the planners told me there won't be capacity addition. Actually, very little was added, but let me add a lot more capacity. Suppose I do that. Then the per capita VMT doesn't decrease. Now it's close to flat. All right, it depends at what point in time you add the capacity and so on. So if you provide people with more roads, then they will travel more, because the congestion will not increase as much. And aggregate VMT will increase even more in that case. Okay, so we observe those results. And if we look at travel time, now we find that is very, very flat. It is actually increasing, but very little, which is what I expect. Because I increased the population of Chicago by about 25% over 30 years, so I expect the travel time to increase by about 2.5% or so. Okay, that's actually increasing less than that in the model. Forget the exact percent, but if you look at this plot, it looks like very little change, almost flat. Okay, the reason for that is every mile becomes more time consuming to travel because congestion goes up. So the system adjusts, jobs and residences move closer to each other, so you reduce the total distance to offset the fact that every mile of distance becomes more expensive to travel. And so the total travel time stays constant, more or less. There's a paper where I've written about this, and I found out that there are several people in the last 50 years or so who measure travel time in various countries and found that people's travel time is very constant in some way. But they never provide an explanation why. Well, this is one explanation. I don't claim this is the only one, but this is one explanation that can be provided, which works on the concept of congestion. And the percentage of people who use transit in car is also very constant. Doesn't change a lot. Travel time per day, now this is commuting plus other time, shopping and so on. It doesn't increase very rapidly. So the system is adjusting, okay? Fuel economy, that means people switching to more fuel-efficient cars, because when congestion goes up, you're traveling at a lower speed. When you travel at a lower speed, you consume more gasoline per mile. That's in the model. And so you become sensitive to expenditure on gasoline, and some people will try to offset that by switching to a more efficient car. So instead of driving an old car, which consumes a lot of gasoline, or a big American car, which consumes a lot of gasoline, you switch to a small American car or a small Japanese car, which is more efficient. That happens, but it's not a very big effect. The percentage changes here are not that big over the 30-year period. And these are aggregates. So if I look at per person things, then these are actually getting better, improving. Why? Because congestion goes up, so I make less trips, which are discretionary. I still have to drive to work. Most people have to go to work almost every day. Some people have flexibility, like university professors. Okay, I go to work not every day, because I spend at least 2 days a week writing at home. But I go to meet my graduate students, I go to teach, I go to faculty meetings and so on. But I can choose which day to go, which day not to go. So I have some flexibility. Most people don't have that flexibility. They have to go to work every day. So they cannot change that very much. They can move closer to their work, reduce the total travel time. But one thing they can change is how many non-work trips they make. They can make fewer non-work trips, right? Instead of going grocery shopping every week, they can go grocery shopping every 2 weeks and buy more stuff that you put in your car and bring home. So that way you save travel time and gasoline if the congestion is high. That kind of thing also happening in the model. And we see that jobs are spreading out. So if I look at how jobs increase over the years during the simulation I did, I find that this is arranged roughly from center to suburban. So you see in the suburban areas, jobs are increasing by a higher percent. The vertical axis is percent increase. Jobs are spreading out to areas that are outlying. And then you can do other things with the model. For example, you can say, suppose I don't add any road capacity. If I don't add any road capacity, I get more congestion, more spreading out of jobs. Because congestion becomes bigger, so more jobs spreading out, or jobs going closer to their workers, less VMT. If I improve transit travel times, then I get less sprawl, less congestion, more transit ridership, and some people moving closer to the center because that's where the transit that is improved is, and so on. And if I don't increase gasoline prices, then I get more people traveling within their own zone. So if gasoline prices are very high, people try to avoid long trips. They try to make shorter trips and so on. So that's going to affect how jobs spread, etc. And if I improve car fuel economy, then I get also what those results are. So let me just continue and go to Paris now. So Paris, totally different situation, but I'm going to analyze it using the same model. Of course, it will be calibrated to Paris, so the parameter values and so on will not be the same. In the case of Paris, we have some important differences. So here is the Paris metropolitan area. In this case, we have broken it up into 50 areas instead of 15 or 14, which was the case in Chicago. Here in the center, you have the city of Paris. The planners look at the city of Paris and say, it is completely developed, there is almost no vacant land, and they don't want any buildings to happen in Paris anymore. So you cannot build a tall building in Paris, it's not allowed. It's very hard to get permission to do it and so on. So they don't want Paris to get bigger. At the same time, they know that if they didn't have such a constraint, Paris would get a lot bigger. A lot of those buildings would be demolished and tall buildings would be built. One reason they don't want it is it makes the monuments in Paris look very ugly. If you have these skyscrapers sticking out, and it makes the skyline of Paris look very ugly. So there are good reasons why you don't want Paris to get bigger. But instead what they do is they have these colored areas around Paris, there's 10 of them, which they want to get bigger. So they want the growth that would go into Paris to be accommodated in these surrounding areas. So they would like jobs in those areas to increase while jobs in Paris remain constant. That's their plan. So they're going to build infrastructure in the future in a way that supports their plan. So what they have is that they have this kind of transit system they are planning, okay, all of which is new lines, about 70 stations and more than 100 kilometers or so. And they want to complete this by the year 2035, and they told us this would cost about 35 billion euros. Now this was all planned before the crisis. Now 35 billion euros is a lot of money, so there's some changes being contemplated. So I suggested them, why not give it to the Greeks and help the Greek economy, and that of course was not a very popular suggestion. I sort of made it jokingly, okay. But you can see that these lines are all circumferential. Right? There's one of them crossing Paris, but the others are all like that. So they're serving those growth centers. This is kind of unusual because most transit lines are radial, but here what they're trying to do is avoid Paris and make it easier to communicate or travel between these suburban growth centers because they want the jobs to go there. They also don't like sprawl. They don't like the jobs to spread out. I'm not saying that's good because under the American experience it would be good for the jobs to spread out. Okay, but they want them to go to the center because they believe in agglomeration economy. They believe that when jobs are near each other, everyone becomes more productive and so on, and they may be right about that. And so they build the infrastructure according to that idea. So the model shows that in fact their idea would work. Jobs would increase more in these places. Okay. So the infrastructure makes a difference in where the jobs go. Now, if congestion goes up and you want to locate your job, you would locate it near these new transit lines because your workers could use the transit lines and come to work, avoiding the congestion. And we also see that rents increase in these areas. So that's obviously because as more jobs want to move in, more people want to move in to be close to the jobs. Some new construction will happen, so the supply of housing, the supply of building floor space will increase, but there is a scarcity to that, so basically rents have to go up because that's where people are going, that's where demand is increasing more than supply, so rents have to go up to bring the two into equilibrium. And so, that's Paris. What would be the effects in Los Angeles? In Los Angeles, study is not yet done, so I'm going to speculate about what I expect to see. And then I may be wrong about some of it. Okay, so as I said before, 2% of the trips are by public transit, and 30% of the jobs on 30 subcenters. That's very unusual. There's a lot of subcenters in Los Angeles. There's a lot of significant concentrations of jobs outside the downtown, which are quite big. And if you add them all together, you get 30% of all the jobs. So that's a city in which we have what we call enormous job sprawl compared to other American cities. And this is the second largest metro area in the US. Right? So why is it so in Los Angeles? Because Los Angeles developed almost completely without transit. And it developed as a city in which there were always a lot of road capacity made available. And so it was very easy to drive from place to place. Of course, over time it got more and more congested. And so jobs spread out. This is why, basically. So remember the regression, Los Angeles is here. Right? That means it's under the regression line. Right? The expected travel time in Los Angeles should be there, but it's under. And you can say what causes it to be under the regression line. And my guess is that it is because of the extra road capacity and the fact that jobs are spread out. So there was an earthquake in the 1990s in Los Angeles, and several important highways just got knocked out, and they were not used for months until they rebuilt them. So I was at the University of Southern California giving a seminar, maybe 6-7 months after the earthquake, and I was explaining a similar concept that if you have less highway capacity, jobs will be more spread out. And in order to explain it, I said, well, suppose you have this awful earthquake, which they expect will happen someday in Los Angeles. It's called the big one. People refer to it as the big one. And then some people think California will fall into the sea or whatever. But one thing that could happen, let's say hypothetically, all the highways get knocked out because they have a lot of elevated highways. If you knock those out, travel within Los Angeles will become extremely congested because people have to use the surface roads. And my idea is if that happens, jobs have to spread out to reach a new equilibrium. That's an exaggerated view of what is actually going on in Los Angeles. So anyway, what we see in Los Angeles, here's the 30 job centers that we identified. So these are identified according to how many jobs and density of jobs and so forth. And if you look at these highways in Los Angeles and put the two together, you see that the job subcenters are always located where there is at least 2 highways crossing each other. Okay. So accessibility is very important. Highways are very plentiful and jobs are spread out. Very little transit is available. So the interesting question is when I apply the model to Los Angeles, after we finish calibrating and estimating the model, we can look at questions like this. One of them is, will there be new job centers that will emerge? Okay, so one question you can ask is, well, maybe there will be a new job center emerging here or somewhere else, which doesn't currently exist, right? So it means jobs will concentrate in some new places. Instead of 30, you may have 35 job centers. Will that happen? Or what might happen is that existing job centers can get bigger or smaller, which means more jobs can be dispersed in such a way that they are not a job subcenter. There's a lot of 70% of the jobs are dispersed in a very thin way. Maybe that will happen. And I expect BNP per capita will decrease for the reasons we discussed before. And the question is how much in Los Angeles? That's it, I think. Thank you very much. Are there questions? Now we can discuss. You can ask me if there is enough time. I don't know, is that? Okay. Yes.
We're discussing here in Moscow. In Moscow, traffic is hopeless, as you could probably see to your own eyes. And there are at least 2 solutions floating around. One is like in London, so directly charging for congestion. And the other is has to do with parking space, which I call Manhattan solution, basically. So you drive wherever you want, you don't have to pay for that, but then they charge exorbitant rates for parking and something. Which of the two do you think is better in terms of coping with congestion? Or are they isomorphic, are they identical?
Cordon tolling and parking charges inside the cordon are very similar.
Okay.
They're very similar. It's very hard to say which is better and by how much. So there's a way in which you measure how good these different policies are by looking at how much of the congestion externality is internalized, because they're both second best. The ideal policy in congestion is every mile gets its own tax. So if I travel 1 mile and there's no congestion, I pay nothing. If I travel 1 mile and I cause a lot of congestion, because everyone who is on the road is delaying everybody else, then I pay a lot and so on. But this is hard to do. No one has done this in the real world where you really charge every single mile. The only case that has been proposed is to do this in the UK for the whole country. A very detailed plan, but it didn't go anywhere. It's sitting on the shelf somewhere. But in London, they did cordon tolling, as I explained, around the downtown. And in Chicago, when we studied cordon tolling in this paper I mentioned that's going to be published soon, I think it just came out actually, what we found is that when you do cordon tolling, you get 60% of the benefit as you would get if you did perfect Pigouvian tolling of all the roads. Okay, so that's in Chicago. In Moscow, it may be higher. Parking is very similar because if you put a parking tax inside where the cordon would be, you're basically getting the same effect. The only people who don't pay are those who cross the cordon. They don't park, so they would not pay the parking tax. But there may be relatively few such trips. So by looking at the data and looking at the travel patterns, one can propose one or the other as being better, but without looking at that, it's hard to say. That's why I say we need models. It's not easy to do this just by sitting around a table and trying to figure out the solution. Yeah, but both of those would be very good solutions, I think. If we can convince people that paying for congestion is reasonable, then these would be potential solutions. They are available to you to do. And you know how they did it in Stockholm. In Stockholm there was opposition to congestion tolling. They did cordon tolling, but not around the downtown, around the entire city of Stockholm. Okay, and what they did is they said, okay, we're going to try it for 6 months, see how you like it, and then you're going to vote. And they did it for 6 months. People were opposed, according to studies, before this trial period, but after the trial period, they voted in favor. Now, voting is not a perfect way of choosing the best solution because a proposal can win by a few votes, but it could be that the people who are hurt by the proposal are hurt more than the people who are helped by the proposal. So it may be a proposal that the economist would not choose, because an economist typically takes the benefits and the losses and balances them out and see what's the net benefit or loss. But it's a good way to solve a political deadlock, a voting mechanism. So in Stockholm they did it, and the reports are that since they did this, people are happy with it, even though they're paying more than they were paying before. So there is evidence that if you explain it well to the population, a parking tax or a congestion tax would actually be approved, because people would see that the congestion goes down and they would begin to see that they were benefiting. And you have a lot of transit in Moscow, so that means the tax you put on congestion is not going to have to be that high to switch people to transit. In LA, it would be defeated by voting. Yes.
As you have said, the idea of sharing one car for several people doesn't really work for the US. Is it possible that it would be effective for some other countries, and perhaps in future, we just have some sort of iPhone application, where it would be possible to find someone, to find a driver, and who would give you.
Yes, I think so. I think. Absolutely. I never assume that what doesn't work in the US will not work elsewhere. But as I said, the behavior is the same. Preferences are different, perhaps. Behavior is the same, but circumstances are also different. So it's possible carpooling would work in other countries. For example, in a culture where people have more friends, you can find more people to carpool with and actually have a nice time in the car by talking about something of interest. Maybe this is easier in Europe than in the US, I can believe it. It might work. And having cars that you can rent and return to the same place, that sort of thing, that can work. It's being done with bicycles in Paris. So having these very small cars that you can rent, that's another way to attack the problem too.
He seems to presenting this model from the point of view like the ordinary person moving from A to B and then sort of like from B to A. How do you think the more realistic view that some person can move from A to B, then from B to C, and then from C to A will differ this model, and what alterations have to be done?
Okay, yeah, that's a good question. So I just use A to B as an example to explain that you want to move closer to your job in order to reduce the effect of congestion on you. But you can do this in several steps if you want. You should really do it in one step, because doing it in more steps will be more costly, right? So suppose I make the adjustment in 5 years and change my apartment every year and move a little bit closer every year, then I have to move my furniture 5 times. Better to do it in one time. Okay, but I'm not saying that it's not okay to do it in steps. People can decide on their own how they want to do it. I don't know, because we don't have that kind of detail in the data to see whether people actually do this adjustment in more than one step or not. We have to infer these adjustments from our aggregate data. We don't have that kind of data.
In your model, so do you think that some threshold time exists, or you are just looking at everything as progressively moving? What I mean threshold time, when, for example, the threshold time for transit. So maybe there is some time that is comfort for some people, but then...
Yeah. I don't believe there's a threshold time. So there's anecdotal examples I can give you. In Tokyo, there are people who commute 2 hours one way. Not many, but there are, which would be almost unimaginable in the States. And sometimes they're tired. They're too tired to drive home. So there are these little hotels where you can rent a little space and just crawl in there and sleep. It doesn't cost a lot of money, right? We know this happens. So there's no threshold. If the circumstances were such, we would all commute much longer. We just have to adjust. Now, of course, they are working on the self-driving car. It's a Google project, and there is a car that actually drives itself, but it's not safe enough. So, and there's all kinds of issues. What happens if such a car has an accident? Who gets sued? Because in the States, we sue each other all the time. So the question is, would the driver be sued? But he's not driving it, actually. He's just sitting. He's the owner of the car, maybe. Or would you sue the company that made the car? And they're fighting about that. But anyway, so sometime in the next 20, 30 years, such a car may be possible. Which means now that commuting is less of a problem, because you can work while you're driving to work. You don't have to drive, so you can do many other things in the car. It may even be better than your home for some people. Okay, so when technology changes, some of these problems may change, and how we deal with them may also change. But right now, of course, we don't have this problem. One of the things we know is that people kind of like being in their car because they can do things, even now, listen to the radio and things like that, which are not as easy to do at home. So there's a radio station, I always listen to it only when I'm in the car. Why do I do that? I don't know. It's a habit I have. But it makes my driving more comfortable. Of course, I don't have a driving problem. It only takes me 10 minutes to drive to work. Sometimes I walk. So I'm not a typical specimen from the United States. Yes?
Does the model explain why one city planners choose public transportations, agglomeration and no skyscrapers in the city, and other city planners choose highways, no public transportation? So
no, the model doesn't explain anything about why city planners do things. What it can do is it can inform city planners. It can say, okay, suppose you want to build skyscrapers in Paris, which is not currently allowed, what would be the effect? We can do that in the model. We can say, okay, let's allow some skyscrapers to be built in Paris, and the model would predict that, I don't know about skyscrapers, but taller buildings would be built. And then the planners can see if they like the consequences of that.
So you don't model the city planner's decisions?
No, I don't model the city planner's decision. The model, however, can help the city planner make decisions. So indirectly, the planner can say, I'm thinking about these decisions. Let me put these in the model, see what happens. What are the costs? What are the effects of congestion? What are the effects on rents, wages, and so on? And then do I still want to do this? Or do I want to do something else? It's used as a tool that a city planner can use to develop their thinking, but it doesn't explain why they do what they do, because they don't use models when they do what they do. They do it some other way, and I don't know how they do it all the time. Sometimes I know what they say they're doing, and most of the time it makes a lot of sense, but I'm not trying to explain that.
You said in the beginning, you said that all city planners behave the same.
No, I was talking not about city planners, but about individuals, people. You and I, we're all the same, basically. We have different preferences, different incomes, different circumstances, but I believe the way we make decisions is similar. And I think this is not just what I believe. Economists really believe that. If you look at the theories economists develop, they are built that way. They are built under the idea that we all maximize utility subject to a budget constraint and so on. We do basically every decision that way. And so economics believes that people are everywhere the same, but they face different circumstances and have different preferences. So that's what I mean. But of course, it would be ideally possible to have a model of how city planners make decisions, but that's not what I'm doing at all. You can be the moderator. You know, better?
Yeah, okay, thank you very much. Just maybe a short overall question. Was like, why those three cities you have chosen for your work?
Oh, why those cities? Okay, so Chicago is a city I picked to study because I've been studying Chicago on and off for years, and a lot of data is available and I know a lot about Chicago. Why am I studying Paris? Because they asked me to.
They asked me.
Yeah.
That was maybe, sorry for interrupting, that was maybe the second part of the question. Have you ever worked with this government, city's government? And do you believe that it's possible to work for like some scientific guys?
Well, in Paris, I mean, I was asked because of these projects, the transit projects I mentioned, to use the model to see what would be the effects of the projects. So I work with a company that's a public company that was created to see this project to come to fruition. And in Los Angeles, because there was an opportunity to apply for a grant from the University of California, I applied and I won, and it had to be Los Angeles. So you have to be, if you want to apply your theories, you have to be flexible to go where the opportunities are to apply them. Right? So if tomorrow they say they want to study Mexico City, and I think I have a good chance to win, I would apply for that also.
So you are not like going to study on the US cities, you can go...
No. Yeah, the model, as I said before...
Maybe Moscow.
Yeah, Moscow maybe, I don't know. I mean, so we are scientists, so we should try to do what's possible. And if you believe that the behavior is similar everywhere, then you want to study as many diverse places as possible to see that what you believe is really true. Yes.
What is the model precision and what input data should you use within such a model?
Right, there's a lot of data that goes into the model. So you can sort of infer from what I said what kind of data you need. You need good data on how people travel, from where to where and how often and so on. You need data on land use, what sort of buildings are in place in different places, how much vacant land there is. You need data on rents, and you need data on incomes from which you can infer wages and so on. So you need a lot of information. And in the US we have good data, so it is a little bit easier to do these models in the US. But I thought Paris had very good data too. And actually France has extremely good data. It's a little hard to get to it because it's hard to release the data from where it is. So if you had more time, you could do a much better model of Paris and get all the data that's available. But we only work with what was immediately available. But there are places where the data doesn't exist, and then they would be hard to model, of course. But without data, you cannot do it.
And overall precision of such model?
Okay, so different ways to measure precision. I don't think any model of this type is extremely precise, so it cannot be used to predict the behavior of a particular person, for example. It can be used maybe to predict how a city will evolve in a generally sound way, but how precisely did it predict? Well, there's very few studies of that, in the sense, ideally what you want to do is, okay, this is what I predicted, did it really happen? Right? But then, in the real world, always something happens that changes things. So, for example, if I was predicting what would Chicago look like today, 10 years ago, I probably wouldn't have put in my model the financial crisis that happened, because nobody anticipated that. Right? That had some effect on what happened in Chicago and anywhere else, because it caused a recession and so on and so forth. Now maybe that's just a blip. Eventually it will disappear. The effect will not be permanent. But those are the things that I cannot predict. And so to say how precisely did I predict things is very, very difficult. I do not claim that there is a lot of precision. Basically what I'm doing is estimating things with econometrics as best as I can. Some things I cannot really estimate econometrically, so I use what I call calibration, and that's used a lot in economics when you cannot really do everything using sound econometrics, and then do some simulations and see if they make sense. And I'm always comparing my magnitudes of elasticities and so on to what's found in the literature and see if they're reasonable and so forth. So I expect that my results are fairly precise, I don't want to say precise, but fairly accurate or fairly robust.
Have you observed or do you have an idea on the facts that actually influence how much time does it take for a city to be ingested to a new economic environment? For example, if a decision was made, for example, to allocate more land for suburb development, how fast the city will adjust to this? Because I do believe that different cities takes different time for this.
Yeah, so in the Chicago model, it was a dynamic model, right? It looked at what happened between 2000 and 2030. And it worked in 5-year increments. So you can do something in 2005 and see what the effect will be in 2010, 2015, and so on. If you remove that, then you see a certain path. If you put that in, you see a different path. We can do this kind of analysis.
What if we concern such places like international airports? You see the places which are not so easy to move somewhere or build another one. As a city grows, they will just collect and agglomerate, I don't know, the traffic near them. So do your models take such places in consideration?
I haven't done that, but you can, because with everything you can, you should ask, can I do this accurately enough? The answer is complicated sometimes, but okay, so let's say in Los Angeles they have 3 airports, suppose they want to have a 4th airport. This is hypothetical. The way they can use a model is say, where should we put it? They can put it here or there and see what are the consequences of that. And based on that, maybe they say, okay, well, the model says we should put it here, but we also have other considerations, political things and various other things which no model can capture. We will also consider those and reach some kind of balanced decision on what they want to do. But the model allows you to do that. Now, one thing about airports is the traffic generated by the airport doesn't depend just on Los Angeles, because it depends on how Los Angeles interact with other places in the world. So what happens in Shanghai has a lot to do with the traffic in a Los Angeles airport, for example. And so you have to make assumptions of what will be the demand for this airport. And that's not something you model, because I don't have a model of the whole world. So I have to assume that somehow and use it in my model.
I would like to ask a question about 2 probably interrelated things. First is 2-income households, where both husband and wife have a job outside the home and they have to commute presumably to different places. And the second, the specificity of matching between jobs and people with specific skills. If it doesn't matter really where I work, if I have some universal skills, for example, I work in the service sector, then really the job can come to me and I can take a job relatively close. If I'm a university professor, I really have several choices to work for, that's it. So if we take it into account, how will the predictions change?
I haven't done that, so I would like to do a more detailed model of the labor market. And I'm always constrained by what data is available. So we have really rough information on skills, basically. We can infer skills by wages and incomes, but we don't have a lot of detail on skills. We have some occupation data in the US, so some of the things could be done at a more disaggregate level. So I can have, for example, a model in which there are 12 occupations in principle. But I haven't done it. I've basically, in the Chicago model, there's 4 income groups, and skills are assumed to increase with income level. So there are a lot of parts of the model that can be improved and done in more detail. And there's always a debate whether that's worth doing. Some people say it's not good to have too much detail in such models, and other people would like to see more detail.
So let's thank you, speaker.
Thank you.